Alright, so let's suppose we talked about the disk method, and so what if there's a gap between our area, our enclosed region, and the axis of revolution? And so this is what we're going to use with the washer method. And a washer, if you know anything about construction, looks like a donut. So when I spin it, it's going to create something similar to a donut. Not in all cases, but just to give you an idea. So if a solid is created by revolving a region around a horizontal axis, it is not flushed up against the line of rotation the volume of the solid is found by. And so we're going to square our r's, our radius, and subtract them from each other. So these are going to be your two functions. If a solid is created by revolving a region around the vertical axis and not flushed up against the line of rotation, the volume of this is found by, and again, the same thing. This one's going to be rotating around similar to like a dx, or similar to the x-axis. This is going to be rotating around something like the y-axis. So this would be, you'd be rotating around y equals something. dy, you'll be rotating around x equals something. I know those kind of, in this case, they're kind of they're different. They're going to be opposites. So if you want to think about vertical versus horizontal, I think that will help you out a lot better. Alright, so I just want to come in and talk about some of the steps for the washer method. First, again, you want to draw your region. Okay, so you want to draw, what's the picture look like? Okay, so let's say this is our area. And we're rotating, in this case, around the y-axis. Determine if this respect to x or y. You want to find your limits. So in this case, what's my lowest y? What's my highest y? And you label your big R. This is going to be the furthest away from the axis of revolution. So my big R is going to go all the way out to the outside edge. My little r is the one that's the closest to my axis of revolution. That's this guy right here. And then you want to set up the formula I gave you of r squared minus capital R squared minus lowercase r squared. Go ahead and integrate and evaluate. Alright, number 1, find the volume of solid found by revolving x equals 2, y equals 2, and y equals 1 over x about the y-axis. So since we're talking about the y-axis, I know that I'm going to be dealing with dy. So 1, 2, 1, 2, and so these are lines. Sorry, that one was pretty bad. That's better. Alright, and so we're talking about y equals 1 over x. So when x is 1, y is also 1. When x is 2, y is a half. When x is a half, y is 2. So we're talking about, maybe I should color it in red so you see it better. So we're talking about this region right here. And we're going to be rotating it around the y-axis. So since we're rotating around the y-axis, I need to change my graph, and so I don't want it y equals, I need it to be x equals. So if I multiply both sides by x, I get yx is equal to 1. And then divide both sides by y, I get x is equal to 1 over y. Some of you guys just know the trick so well that you probably just flip them, and that's fine. And so you can see our lower bound is going to be a half, our upper bound is going to be 2. My big radius is this guy. There's my capital R. My lowercase r is the one closest. to my axis symmetry. And so when I set it up, I'm going to do big R, R squared minus little r squared. So we're going from a half to 2 times pi. I'm going to put pi on the outside because I'll deal with that at the end. And then I'm going to do capital R squared, which is, since this is 2, this will be 2 squared, minus 1 over y, and I'm going to square that as well. So this becomes pi, being integrated from 1/2 to 2, 4 minus 1 over y squared dy. Let's go ahead and move that y up so we can take the antiderivative. And so this becomes pi times 4y plus y to the negative 1. The reason why it becomes plus is if I divide by negative 1, a negative times a negative becomes positive. And evaluating that from 1/2 to 2. And then I ran out of room, so I need to come back up here. I'll borrow some space on the other side. Which is, let's see here, pi times 8 plus 1/2 minus pi times 2 plus 2, and then if I simplify all that out, I get 9 pi over 2. There we go. Alright, now we're going to be using our calculator. Find the volume of solid generated by the graph bounded by y equals x squared and the line y equals 4 when it's revolved about the x-axis. I'm going to go to y equals, and I'm going to plug in x squared. And then for y2, I'll plug in 4. I just want a graph to get a good idea for a picture. Since we're revolving around the x-axis, it's going to be a washer because they're not completely flushed up against. And so I want to find my points of intersection. Looks like it's going to be from -2 to 2, but just double check. So I'm going to do intersect, first curve, second curve, and then I get one of them is 2 to 4. So I know that over here it's going to be -2 as well. So we know our bounds. We're going to do, in this case, top minus bottom. And so my capital R is going to be 4. And so it'll be 16, 4 squared, 16, minus lowercase r, which is going to be the parabola. So it would be x squared squared, which would be x to the 4th. So we can just go back to our home screen and just set it all up. So I'm going to do second pi, that's our coefficient, and then math 9. And I'm going to go to variables, y variables, function, I'm going to do y2 and square it, minus, again back to variables, y1, square that one as well, and then comma, our independent variable x, and then -2 to 2. And there we go. That's the volume of our washer.